We will learn to compute the z-scores and the measures of dispersion, variance and standard deviation. We take a very simple example so that we can manually verify it and mentally compute these values ourselves while we are implementing using Excel. We start by computing the mean of the values in the data set. We use the formula average, which is 3. Next we compute the relative distance of the values in data set from the mean, which is x minus mu. So we see that 1 is 2 units below 3 and 4 is 1 unit above 3. That's the relative positioning. The challenge with this is these dispersions when added together gives us a value of 0. So we are not able to calculate on an average how much of dispersion or how much of deviation we have from the mean as they add up to 0. So what we do is we take the squares and add those. So we are essentially eliminating the negative and positive value deviations to a single directional deviation. Power 2. And then we compute the sum of this, which is our total deviation in this data from the mean. And these deviations are in form of the square. So we call it as sum of the square of the deviation, also called as the total variance. The average of these deviation divided by 5, as there are 5 values, is called variance. Since we have squared up these deviations, this is in form of square, so we find the square root to find the standard deviation. And we get the value of 1.414. Now we have the standard deviation and we have the relative deviation from mean. We rescale these deviations in multiples of standard deviation by dividing it by 0 is equal to the deviation divided by standard deviation. This gives us the relative positioning of the values in the data set in multiples of standard deviation. It is also called as z-score. So we can say 1 is 1.41 standard deviations away from 3 on the lower side, and 0.71 indicates that 4 is 0.71 standard deviation away from mean above the mean. That is how we compute the z-score and interpret it.